Welcome to this session on concept mapping. I'm Sid Bundy, and in addition to being an accounting professor, I'm a caver. I'm fortunate to live in Tennessee, which is home to over 10,000 known caves, many of them discovered by my friends and me. You may be asking, what does caving have to do with building a concept map for my auditing course using an iPad? Well, I'm glad you asked. Hang with me, we'll get to that in just a moment. You see, not all cavers are the same. Cavers have diverse interests. Some are hydrologists, geologists, biologists, paleontologists, anthropologists. Others are explorers or cartographers. We're going to focus on that last one today, and I'd like to encourage you to shift your role in the classroom from explorer or tour guide to cartographer. Cartography is the science or art of making maps. You probably already know a lot about cartography, and I'm sure you can remember your third grade social studies lessons about legends and to never eat soggy waffles. You'd no doubt recognize lots of maps, even ones depicting fantastical places. And you can probably name several famous cartographers, artists who changed the way we see the physical world. You might have even watched John Green's TED Talk about fictitious towns being willed into existence because a map maker drew it thus, or read about this phenomenon in his book, Paper Towns. Mapping caves poses several unique challenges. First, by definition, a cave is underground and is dark, so the explorer or cartographer lights each passage one step at a time as it's discovered. No LiDAR, no GPS, no satellite imagery. Often you can't see the connections until they're illuminated. Second, a cave map has more than 3 dimensions. I'd like for that to be some sort of interdimensional wormhole. However, it's much more like an actual tunnel left by an earthworm. You have to map the 3 dimensions of the cave, the height, width, length, and length of passage, crack, or pit, and then the depth and direction and length of its position in the earth. We often find layers of passage like Swiss cheese or bowls of noodles. In education, intentionally building links to prior knowledge stems from John Dewey's theory of constructivism. Long considered the most important factor influencing learning and student achievement, prior knowledge is a multidimensional and hierarchical entity that is dynamic in nature and consists of different types of knowledge and skills. When students learn something without these connections, it results in rote memorization, a very superficial kind of learning. To me, that sounds like the human noodle is pretty much like a bowl of cave passage noodles. So maybe, drawn carefully, multidimensional maps could help students make connections and make sense of dark and complex content. As it turns out, research shows that just such maps are terribly effective at doing just that. The maps we build in education are called concept maps, knowledge maps, or mind maps. Concept maps place the main idea at the top and focus on hierarchy, and mind maps place the main idea in the middle. Lots of studies over the last 3 decades show that mind maps increase student achievement, knowledge retention, and motivation. We know this. We make maps, we encourage our students to make maps, and you're here to learn how to make better maps using your iPad and to use those maps within your online learning platform, right? I thought so. So let's get started. In caving, we take measurements and draw sketches in the field, but most of the actual drawing is actually done here with the help of specialized software. I've used a lot of different techniques to build maps over the years, from big flip charts to overhead transparencies to Prezzies to Doodle, but right now I'm in love with Miro. It's a subscription service, but you and your students can download the app and build 3 boards for free. Each board is basically limitless, so you can have 1 board per course and build maps for 3 courses. Here's how it works. First, go to your app store and download the program. There's no reason to have scratch paper with this program, but you might want to know where you are and where you want to go, and maybe have a few steps or pieces of content along the way. Or you may want to start with chapters and modules and then work or zoom your way down. After setting up an account, you can jump right in with your pencil and build a map using one of the preset templates, or from scratch using basic smart shapes and sticky connectors available in the drawing tool. I begin any map with 3 to 5 main ideas. I draw them as basic shapes and connect them with arrows. All connected elements in Miro are sticky when resized or moved, and this allows a lot of flexibility as you design the map. You can rearrange elements very easily. I particularly like using my Apple Pencil in this application. I centered my audit map on the risk-based model and built out from that with stops for auditing strategy, audit procedures, sampling, audit reports, and so on. After connecting my major concepts or chapters, I can drill down into each. Today, I'm working in the assertions from SAS 80, which I visualize using a purple star. I might carry that same purple star into my SAS 106 lectures covering the assertion classes. With its tremendous depth of field, the free access to 3 boards is a generous place to start working with the tools. Perhaps a more powerful way to use Miro is to turn your students into cartographers, where student teams work together to build and find connections. Virtual sticky notes are available, and a quick access bar gives you standard tools for word processing. You can group objects, move objects, and resize objects on the workspace or board, which feels spacious as you pinch and zoom. This map is not two-dimensional. Hierarchy is visualized by size. Zoom all the way out and you'll see modules. Zoom in and get detail of a single definition. In the intro, you saw a two-dimensional concept map and mind map drawn in Doodle. Doodle and Toonly are cool, but Miro is more powerful because it's three-dimensional. The board resets at 100%, so working in that depth is most convenient. I recommend creating your elements and making connections first, and then going back and editing visualizations. You can make small changes forever, so this allows you to better budget your time. Frames allow you to form less temporary groupings that can easily be named, resized, and duplicated. Miro automatically creates an index of frames, which will help you navigate larger boards and move between topics during a presentation. You've seen some basics now. Do you want more? How much more? I can link to the web as I touch on a frame. I can build out a chart and give it a name. I can bring in a video and set up a wall, but that's not all. Oh no, that's not all. I can invite my students to join the fun. I can give them a team challenge to Miro they run, and a virtual boards they can all join in and connect waffles to titans to cavers with friends.
Don't panic. You found it.
And this is the part you know it is true that I post my Doodle videos for you.
Survival guide to audit sampling.
During the live session, I'll demonstrate some of the features of Miro and build portions of maps from their templates and from freehand. I'm including high-speed walkthroughs of how to add elements, connections, frames, hyperlinks, and videos so you can come back to them after the session. We'll also discuss the workflow in my live session. I create videos with Doodle, my GoPro, my IPVO document camera, and using screen capture feature on my iPad. My voiceovers are recorded on my desktop using a Samsung Meteor mic that costs about $60, and I store all the files on my OneDrive and edit it from my couch on my iPad using a subscription program called LumaFusion. Uploading can be cumbersome, so I do that overnight. I upload all the videos to my media in D2L. Some storage challenges force me to upload to YouTube when I don't have time to fiddle with a workaround. Shoo, we're 7.5 minutes in and we've been through a lot. I want to leave you with some quick tips. Number 1, don't forget that the goal of mind mapping is to make intentional connections between concepts. Be sure to anchor any new material to concepts that were very firmly stored in long-term memory. Go all the way back to 3rd grade if you can, all the way back to the Cat in the Hat. Don't try to be funny. Jokes are short-lived. Instead, try to anchor to things that your audience finds very, very interesting. We pay closer attention and remember more when we're mindful of the things. Reinforce, restate, repeat, buttress. Establish hooks and motif. Think musicmatically. Alexander Hamilton. Extend those repeats to visuals, where a green plus sign reminds you of John Dewey or a particular ship, signals explorers and cartographers, and a single thumbtack triggers every detail of a TED Talk you watched or a book you read in 2015. Most importantly, don't forget to get your students involved. The best learning is active learning, so post this challenge on Friday along with the reading assignment that you want them to have completed by Monday morning. Prepare a mind map that connects waffles to the Tennessee Titans, to the author of the last book you read, and to the main idea of the reading assignment that I just gave you. Research suggests that they'll be more motivated to read and remember the content longer if they are the cartographers. But for heaven's sakes, let's all agree that if we're not going to do that, if we're going to send them out in the dark, we should at least give them a map.